So now we'll jump to graphing of the remainder of the trig functions. We'll start with tangent, and we'll go about it the same way we did last time. We'll take and look at the axes points. So we'll look at 0, pi over 2, pi, 3 pi over 2, and 2 pi, and check all the tangent values there. And remember, tangent's just the y over the x value. So if we look at the y over x at 0, we're at 0. If we look at the y over x for pi over 2, we notice that we have 1 over 0 here, which is undefined. So I'm going to take and put in, like we do for all undefined values, an asymptote right at pi over 2. And then I'll go back and say at pi, again, we have 0. And at pi over 2, notice again, we come up with negative 1 over 0, which is an undefined value. So again, I'm going to put an asymptote right here. And then at 2 pi, we're going to have the same value as we did at 0. So now I get an issue because I've only got 3 points, no points to connect. I'm kind of in trouble. So what I'm going to do is I'm going to take values at some pi over 4 points. And I'm doing that because I know at each pi over 4 point, I have the same x and y coordinate of root 2 over 2 and root 2 over 2. Obviously, they'll vary in positive and negative values, but here's the pi over 4, and I get a value of 1 for the y over x. So this guy is going to go here. In the second quadrant, I have a negative 1. Third quadrant, positive, because I have 2 negative values. And fourth quadrant, negative. So there's one thing we can see right off the bat is that I have more than one period here because this graph repeats. Notice I'm going up, and then I continue to rise, I get back to 0, and then I repeat what's over in this first section over here. So my period, here's, in theory, a cycle of the graph, and my period is equal to pi. So then I have some calculations involving k of period equals pi over k instead of 2 pi over k, or 180 over k. All right. And then we have to bring up a question of, all right, what is our domain of the function? Well, it looks like I'm going to get asymptotes every pi over 2 and pi thereafter. So if I want to write a domain, I say the x's are not equal to pi over 2 plus pi k, and k references integer multiples of pi from there on out. Whereas the range, notice, it goes up and down forever, so negative infinity to infinity will give me the range. So now we move on. We'll do cotangent now. Put in all those spots again. 0 pi over 2 pi, 3 pi over 2, 2 pi, and we'll notice at 0 now, you'll notice I have, since I'm looking for x over y, I have a 1 over 0, which is undefined. So now I have an undefined value, or an asymptote at 0. And then I go to pi over 2, and I get a value of 0. Back to pi again, and notice undefined. 3 pi over 2, 0, and pi, or 2 pi, sorry, is the same as 0, like so. So now again, I have this issue with just dots and asymptotes. Can't really connect anything. So I go and I'm going to look at that pi over 4 value again. And at pi over 4, I get a value of 1. At 3 pi over 4, I get a value of negative 1. So notice this goes down like so. And it's much easier on the cotangent value to see the repetition. And we notice here that our period here is also pi. And one thing you notice between cotangent and tangent, the difference, tangent's always rising, it's going up from left to right, whereas cotangent is always falling from left to right. Domain, similar but not the same. You'll notice that I have every multiple of pi, I have an asymptote, so we can say is not equal to pi k. And then again, from negative infinity to positive infinity for your range. Secant, I go ahead and do my markups. We're at 0, 2 pi, 3 pi over 2, 2 pi, and I start looking at 1 over my x value. So I look at my x value in this case, and I have a value of 1. I look at my x value here, and I have a 0 for my x value, and the reciprocal of 0 is undefined. So I have an asymptote here. And while I'm at it, let's find another 0 value right here. There's another asymptote. I go to pi, I have -1 for a value, and that's reciprocal is -1. And then at 2 pi, it's the same as I had for 0. So I have my 1 value again. Again, issues here. Now, in this case, finding the reciprocal of x values is going to be not hard, but you want to probably pick the right one. So I'm going to pick the one at pi over 3, which is a half. And I take the reciprocal of a half. Pi over 3 is roughly here-ish. And that's 2, so it's going to be somewhere here. Basically, it's going to go up this way. And then I go over to this side, and here's my negative half. And that's down here-ish. So it's -2. And then it's the same on the other side. Again, here's -half. Like so, and this guy goes here. Now, if you look for a repetition in this picture, there is no repetition. I'm going up, curling up, going down, going here. The only repetition is going to happen when I start doing this again over here. All right, so this has a period of 2 pi. And I do my 2 pi over k calculations like I would for sine and cosine. The domain in this case, you'll notice here they are at pi over 2 and every pi thereafter. So it's very much like our tangent graph, if you will. So it's pi over 2 plus pi k. And those are the values that are not equal to x. And now our range is a little different because I've got this giant gap in here. So I'm going from negative infinity to -1. This would actually be included in union with 1 to infinity. So cosecant works in a similar way. Get my points of interest again. I'll put the values where I have 1s for the y. Remember, this is 1 over y. And I have a value of 1 here, -1 here. And all my other values bring about zeros. So I know I'm going to have asymptotes at all those y values of 0. So again, I'm going to look for pi over 3, or actually I'm going to look for, in this case, pi over 6 values, because in my pi over 6 values, I have half as my y's. So pi over 6 will be somewhere around here, which gives me a reciprocal of 2, like so. And then, again, it'll happen over here, 5 pi over 6. And then over in this case, my pi over 6 value will be here, and that's a -half, so that's a -2, like so. Domain, notice that every multiple of pi And range is very similar, negative infinity to negative 1. And these are all equals, though, in this case. And 1 to infinity. And again, the period is 2 pi. So now that we have all these graphs, we're going to go ahead and do some translating. So I notice here I've got a tangent functions, which means the period is equal to pi over k. And in this case, it's already factored for us. The k value is 2. So that's equal to pi over 2 is my period. Now, we're looking at where our period occurs. Let's go back to our tangent function real quick. In our tangent function, our cycle is pi, and if we look at how many quadrants we go through to get to that pi, here's the first quadrant, and here's the second quadrant. So there's 2 quadrants. So instead of finding my intervals by dividing by 4, we're going to take and divide the period by 2. So the intervals in this case are pi over 2 over 2, which are really pi over 4. All right, and we're going to go ahead and graph one period. Let's just do that. I know I have a couple of things happening. I know that I have a phase shift of 10 degrees going to the right, and I have a midline at 1. So let's throw all this stuff in. My midline at 1, I'm going to put right here. I start, instead of at 0, I'm going to start at 10. And so we're going to now adjust this. Should have done that ahead of time. Instead of in terms of pi, since we're in degrees, I'm going to say 180 over 2, or 90. And then if I divide 90 by 2, I end up with, and now if I divide 90 by 2, I end up with 45. So add 45 to 10 until I get to a total of 90 degrees. So I have 55 and 100. Notice that's a total of 90 degrees. One period of tangent should occur there. I know in a normal tangent function, notice there's no y multiplier in this case. I would start at the midline. Then I would throw at the next interval an asymptote in, and then I would get back to the midline. And I know tangent always rises, so there's my graph. The domain in this case, you'll notice that it's a little bit tough to see that domain, but if I were to carry this graph out just a little bit, add 45 more degrees, right, and get 145, you'll notice from 55 to 145 where my next asymptote would be, like so, I would have a total of, just going to put a dotted line there because I only want to graph one period. You'll notice that I have a total of 90 degrees between my asymptotes. Therefore, the domain can be stated as, well, it's not going to be 55, and any multiple of 90 degrees thereafter. The range is all real numbers again. And the problem is done. So here's a cotangent function, much like a tangent function. First thing we're going to have to do, though, is we're going to have to take and factor. So this goes to cotangent of 3 times x plus pi over 3. Period. Just like tangent, we're going to get, instead of 2 pi over k, we're going to go pi over k, so it's pi over 3. Intervals, we're going to divide that by 2. So So that's pi over 6. And we have a phase shift of negative pi over 3. So that ought to get me started at least. Let's start at, instead of negative pi over 3, let's make that sixths. So that's negative 2 pi over 6. We'll start there, like so. And then we increase by pi over 6, so that's negative pi over 6. And that's going to be 0. Cotangent, we know, has an asymptote on the first interval number and then goes to 0 and then has another asymptote, and cotangent will always decrease, so it's going to look something like this. Range, we can see, is all reals. All right, and then the domain, we're going to have intervals every pi over 3, starting from 0 on, because this will repeat itself, obviously. We'll go to pi over 3 again, or 2 pi over 6. Get another one of those guys here. I'm just showing you 2 intervals instead of, or 2 periods instead of 1. So you can see that this goes in terms of, we can stay 0, but I won't. I'll go pi over 3k. And k can be plus or minus, so either way. Now we graph a cosecant, where in terms of radians, it's not in the correct form. We'll go ahead and factor. Like so. Now I'll get my values going here. We have a cosecant, which is a period of 2 pi. So period in this case is 2 pi over k. K in this case is a half. So 2 pi over a half is 4 pi. Our intervals are dividing by 4. So 4 pi over 4, which is pi. Our phase shift appears to be 3 pi over 2 of the negative type, so that goes to the left. And notice I'm going to change my intervals to, in this case, we'll change those to 2 pi over 2, like so. So we can match these guys up. And I have no amplitude change and no midline change, so I'm going to start plotting things. I have a start at negative 3 pi over 2. And I add 2 pi over 2 to that until I get to a total period of 4 pi. So add 2 to that, and I get negative pi over 2. 2 to that, and I get pi over 2. 2 to that, and I get 3 pi over 2. And 2 to that, and I get 5 pi over 2. From negative 3 to 5 is a total of 8 pi over 4, which is 4 pi. So that's going to be an entire period of cosecant. Again, at cosecant, I know I start cosecant at asymptotes, and every 2 intervals after has another asymptote. This is the reciprocal of sine, so my first interval is going to have values at 1, my third at negative 1, and I know that reciprocals look like this. And then I can go ahead and state my domain. You'll notice I have basically 4 pi over 2 between asymptotes, and I can start at any asymptote I want. I'm just going to do this. I'll go pi over 2 plus 2 pi k. That's where it's not equal. And then my range in this case is going to go from negative infinity once again to 1 and sorry, that's a negative 1 and 1 to infinity. So now we have a midline change and we have an amplitude change, not in correct form, so let's go ahead and work with that. 5 secant, pull the pi out, be left with x plus a quarter minus 1, have an amplitude. Well, let's just do the period first. Period equals 2 pi over pi, or 2 in this case, intervals, divide by 4. So I have a half. I have an amplitude of 5. I have a phase shift of negative 1/4, which means it goes to the left. I have a midline at negative 1. So I'll go ahead and start marking that up. Here's my negative 1 value. I'm going to now mark, if I'm moving 5 up and 5 down from that, to highs and lows, if you will. I'm going to go up here to 4, go down here to negative 6, all right? And then I'm graphing secant. So I know that when I graph secant, let's not get ahead of ourselves. So now let's put in all my interval values, starting at negative 1/4. I'll change my half, since I want to be counting appropriately, into 2/4. So I'll add 2/4 all the way up. So this is positive 1/4, 3/4, 5/4, 7/4. Between negative 1 and 7 is 8/4. 8/4 is 2, so my whole secant graph should appear here. I know in secant, I'm going to start at values of 1 at my first interval, but now I'm multiplying that value by 5. So now I'll put this value up here. And then after that, I'll have an asymptote at my next interval. Go down to negative 1, but now we're multiplying. Negative 5. I go through another asymptote. And then I'm back to my value at 1, which is now 5. And we take and draw our graph from there. So I know this goes up. It's going to go down. This goes back up. My domain in this case, you'll notice between asymptotes, we have 4 pi over 4 or 1. So I can say this is not equal to 1/4 plus integer multiples of k. My range in this case is a little bit different. So I'm going from negative infinity to negative 6, and from 4 to infinity. So again, didn't put it in, however, the intent was horizontal is in radians. So like I said, we had 1, 2, 3, 4 as our period. So if our period's 4, 4 equals pi over k, therefore k is equal to pi over 4. Now, normally I have an asymptote at the start of cotangent. Well, I look at my asymptotes here, and I could either say I've got an asymptote at 1 or an asymptote at -3. I'll just go with the asymptote at 1, let's say. Pop that guy right there, which means my graph has shifted to the right 1. So phase shift is equal to 1. All right. When I give you cotangent problems and tangent problems, it's really tough to determine amplitude. So I will not give you anything but ones when I'm asking you to write equations from a graph. So we're going to just assume my amplitude is 1. All right. And I think the midline has changed since I've drawn this horizontal to 1, 2, 3 up. So now I should be able to write this. I have the cotangent. I need my k value, which I have of pi over 4. X minus 1, since it moves to the right, plus 3 should be my equation for this graph.